Okay, so the second problem that we are doing is this problem here, right? So in this problem, we have um, an input which we are told is 5 volts peak to peak. We have a diode, and then we have this 100 ohm resistor connected here, and we're measuring the V out across this resistance. Okay, so I mean, from the lectures, you know that this circuit is a half wave rectifier, isn't it? So uh, we, we'll just remember that, and we'll use that to solve this problem instead of going over the theory of the half wave rectifier again. Let's just do that. And if you are not very clear with that, you can go back and watch the videos on half wave rectifier. Okay, so we know that. So let's look at part A. So we know that half wave rectifier works like this, isn't it? When V in is greater than 0, we have V out equal to V in, and when V in is less than 0, we have V out equal to 0. You can put the equality on any one of these conditions. So how would the graph of the output look, or the output and the input both look? So the input is going to look like this, isn't it? So this is 0 volts. Remember, the question says that the signal has a average voltage of 0 volts. So that's your average, and on top of it you have your signal, which is 5 volts peak to peak. Now what do we mean by 5 volts peak to peak? Well, what we mean by 5 volts peak to peak is that this amplitude from the from one peak to the next peak, this entire thing is 5 volts. Okay, now what is the output of this circuit going to be? um, let's plot it here. So yeah, the output of your circuit here is going to be something like this, isn't it? This, and then you'll have a negative part where it is 0 in the negative half cycle, and so on and so forth. So in this case, what is the peak output voltage? So what the question is, what is the peak output voltage? So the full peak of your so the peak to peak value of your circuit is 5 of your input is 5 volts. So what is the value of this peak, right? Of the value from, what's the value from here to here? It's half of 5, so it's 2.5 volts. So the peak to peak value of your output is 2.5 volts. Now in the solutions, I say it is 5 volts, which is wrong, isn't it? So let's just uh, you can correct that. Okay, now the part B asks you to find out what is the average voltage. Let's do it on another slide. So how does our output look? So let's write B. How does our output look? Our output looks like this, isn't it? So it's basically signals like this in the positive half cycle, and then you have zeros here. So it doesn't matter what your signal is, like what the frequency of your signal is. If you call this 0 and call this time t and this time 2t, right, the average of the signal from 0 to 2t will be the average of the entire signal, because the signal is periodic, right? So how do we find the average of the signal? If remember from your calculus, my guess is you should remember that v average is equal to integration of 0 to 2t v out t, right, divided by 2t, right? So this is what we want to calculate. So how are we going to do that? So you can see that this becomes, you can divide this into two uh, parts, right? 0 to t, and in 0 to t your signal looks like, I mean, you can write cos or sine. Let's say your signal was sine omega t dt. Okay, let's be a little bit more careful here. It's not just sine omega t, isn't it? It's 2.5 sine omega t, because the amplitude is 2.5 volts. Does that make sense? Okay, good. Plus, what's the value from t to 2t? 0, right? 0 dt. So you can ignore this term because that just amounts to 0, and we'll calculate the first term. So you get 2.5 divided by 2t, and you have an integration of 0 to t. And what's the integration of sine omega t? Well, if you remember, it's going to be minus cos omega t over omega. That's your integration. Oh, I should take away this integration sign, isn't it? Because it's no longer an integration. And let's correct this and make it 0 to t. All right, so let's substitute the values, and what do we get? What we get is 2.5 divided by 2t, and you get minus cos omega t divided by omega minus of minus cos omega c times 0 divided by omega. Okay, and this turns out to be 1.25 divided by t times, well, omega t you can take out, isn't it? Omega t, and then you get let's see, so this term becomes cos 0, so that's 1, minus minus cancel out, the plus 1, so 1 minus cos omega t. Okay, now let's ask the question, what is this omega t, right? So what is omega? Omega is 2 pi f, right? And what is f? F is 1 over t, right? And so omega and t are related, and so you can write this as omega t equal to 2 pi. So substituting that in this equation, what do we get? Oh, I'm sorry. Let's see here. So f is 1 over time period, but here we assumed our time period. Look at the time period. We didn't assume the time period to be t. We assumed it to be 2t, right? So this is going to be 2t. So omega times t is going to be what? Pi. Does that make sense? So what I'm saying is that the time period of your sine wave is the inverse of the frequency, and that's what we have substituted here. But in this case, the time period, we have taken it to be 2t here, not t, and therefore f is equal to 1 over 2t, and omega t becomes pi. So let's and if you substitute that here, cos omega t, which is cos pi, is minus 1, so that will become 2, and this omega t is of course pi. So what you get is this becomes equal to 2.5 divided by pi, and that is your average voltage of the signal that you have at the output. Okay.